Hey everyone, welcome back to the channel. I'm excited because today we're demystifying NLP, short for Natural Language Processing. In the next 15 minutes, you'll get a friendly, practical tour, what NLP is, how it works, the key building blocks like tokenization and embeddings, why transformers changed everything, plus hands-on tools and next steps for you. Whether you're a curious beginner or a developer wanting to add language features to your apps, this video will give you a clear roadmap and real-world intuition. Stick around for the demo examples and a quick checklist to start your own NLP project. Let's jump in. First, what is NLP? In short, natural language processing is the field that enables computers to read, understand, and generate human language. NLP sits at the intersection of computer science, linguistics, and machine learning. Everyday examples you already use: autocomplete on your phone, spam filters, voice assistants like Alexa or Siri, translation tools, and the summaries you get from meeting transcribers. NLP systems turn raw text or speech into structured signals that machines can reason about, and they can produce text or actions back in human language. The goal is to make human-computer communication natural and useful. Why should you care about NLP? Because most human knowledge and communication is expressed in language. Unlocking language data powers better search, smarter automation, faster insights, and more natural interfaces. Businesses use NLP for customer support automation, sentiment analysis, compliance monitoring, and knowledge extraction. For researchers and product teams, NLP enables building tools that scale human expertise and make information accessible across languages and formats. As models get stronger, the impact grows, from saving analysts hours to building conversational agents that help customers instantly. That's why NLP is a key lever in modern AI strategies. Before we go deeper, let's cover a few core NLP concepts and terminology you'll hear a lot. Tokenization, splitting language into units like words, subwords, or characters. Syntax versus semantics. Syntax is structure, semantics is meaning. POS tagging labels parts of speech. Named entity recognition extracts names, places, organizations. Parsing analyzes grammatical structure. Corpus is a dataset of text. Pre-training means training a model on lots of unsupervised text before task-specific fine-tuning. Understanding these building blocks will make the rest much easier to follow. Good NLP starts with good data. Pre-processing steps include text cleaning, removing HTML, normalizing case, tokenization, word or subword, handling punctuation and numbers, and sometimes lemmatization or stemming to reduce words to their base forms. For speech, you need ASR, automatic speech recognition, to convert audio to text. Annotation is crucial for supervised tasks. Think labeled intents or entity spans. The quality of pre-processing and labels often matters more than fancy models. So build pipelines that are reproducible and document what you do. Outer machines represent words and sentences. Historically, bag of words and TF-IDF turn text into vectors based on term frequencies. Modern NLP uses dense vector embeddings where words, phrases, or entire documents are mapped to continuous vectors that capture semantic similarity. Examples: word-to-vec, glove for word embeddings, and sentence transformers for sentence-level embeddings. Embeddings let you compute similarity, cluster concepts, or feed compact numeric features into downstream models. Think of embeddings as condensed meaning vectors that machines can compute with. NLP models evolved from rule-based systems to statistical models to deep learning. Classic approaches used feature engineering with logistic regression or SVMs. Then, RNNs and LSTMs handled sequences, improving tasks like translation and speech. The big leap came with transformers in 2017, which use self-attention to model relationships across an entire sequence in parallel. Transformers enabled efficient scaling, leading to models like BERT for encoding and GPT for autoregressive generation. Today, transformer-based pre-training and fine-tuning dominate state-of-the-art NLP. Let's zoom into attention, the core idea behind transformers. Attention lets models weigh the importance of each token relative to others when producing a representation. Imagine asking, what does it refer to in a sentence? Attention helps the model focus on the correct antecedent by computing soft alignment scores. Multi-head attention runs several attention computations in parallel to capture diverse relationships. Intuitively, attention is like a dynamic, learned lookup that determines context-dependent importance, and that's why transformers handle long-range dependencies so well. How do we train modern NLP models? Two main phases: pre-training and fine-tuning. Pre-training uses massive unlabeled corpora with general objectives: masked language modeling for BERT or autoregressive next token prediction for GPT, to learn language patterns. Fine-tuning adapts the pre-trained model to a specific task using labeled data, often with much less data and compute. Transfer learning via pre-training makes NLP practical. You start from a general model and specialize it. There are also techniques like few-shot and prompt-based learning that reduce labeling needs even further. Evaluating NLP depends on the task. For classification tasks, we use accuracy, precision, recall, and F1. For generation tasks like translation or summarization, common metrics include blue, rouge, and meteor, though they don't capture human judgment perfectly. Language models also use perplexity as a measure of how well the model predicts text. Increasingly, human evaluation and task-specific user metrics matter most because automated scores can be misleading. Always pick metrics that reflect real-world success for your application. Now let's talk tools. Want to build NLP quickly? Use libraries like Spacey for fast production pipelines, NLTK for educational tools, and Hugging Face transformers for state-of-the-art models and easy fine-tuning. For large-scale retrieval or vector search, check out Face or Milvus. For building conversational agents or chaining models, try LangChain or Rasa. Many cloud providers offer managed NLP APIs if you need quick results. My tip? Prototype with Hugging Face and Spacey. Then scale with vector DBs and orchestration tools when you're ready. Let's run through concrete applications. 1. Chatbots and virtual assistants for customer support. 2. Search and semantic retrieval using embeddings to find relevant documents. 3. Summarization to condense long reports or meeting transcripts. 4. Machine translation to break language barriers. 5. Sentiment analysis for brand monitoring. And 6. Information extraction to populate databases from unstructured text. In a demo, I'd show a quick embedding search and a summarization example. Think of using one model to find the best answer and another to rewrite it clearly for users. NLP is powerful, but comes with challenges and responsibilities. Models can amplify bias present in training data, leak private information, or hallucinate incorrect facts. There are also concerns about fairness, accessibility, and misuse, like generating misinformation. Addressing these issues requires careful dataset curation, bias audits, red teaming, differential privacy techniques, and human-in-the-loop systems. As builders, it's crucial to evaluate not just model performance, but societal impact, and to design fallback behaviors and transparency for users. If you want to get hands-on, here's a practical learning path. 1. Start with basic Python and machine learning concepts. 2. Learn text preprocessing and classical NLP, NLTK, Spacey. 3. Experiment with embeddings and small transformer models using Hugging Face. 4. Build small projects, a Q&A bot, a summarizer, or semantic search app. 5. Study evaluation and ethical considerations. 6. Explore deployment, APIs, Docker, and vector databases. Practice by reading papers, following tutorials, and contributing to open source. Small, consistent projects beat passive learning every time. All right. Quick recap. NLP turns language into signals machines can use, embeddings capture meaning, transformers and attention underpin modern breakthroughs, and practical success depends on data, evaluation, and ethical design. If you enjoyed this overview, hit like, subscribe, and ring the bell for more practical AI and NLP videos. Drop a comment with what you'd like to see next: a hands-on Hugging Face tutorial, building a chatbot, or a deep dive into attention math. I'll post links and resources in the description. Thanks for watching, and I'll see you in the next video.